Hello, I am going to make hopefully what is quite a short video and just show you what we might be able to do in order to encrypt text and create some kind of little encryption program. So I'm going to work in idle, but obviously you can work in any IDE that you like to work with Python. Idle I'm going to use just because it is very accessible by anyone, and this is supposed to be nice and beginner friendly. So what I'm going to do is I've gone to File, New, and I've created myself a new file. So this here is the shell, and that's where we're going to run our code. You know it's a shell because it's got these three little arrows in it. Okay, this is our program. This is left blank, and this is what we're going to be writing all of our code in. Now I need to save my program. Don't save the shell; it's useless. Make sure you click on your program and you save this. I'm just going to do a quick save. And let's pop it on my desktop just for now, and we'll call it Encryption, and let's press save. Okay, sweet. So how are we going to start? Well, let's start by getting an input from the user. So let's call it plain text. I'm going to call that's going to be my variable name, and my plain text is going to equal to input enter phrase to be encrypted. Great. We could think of this as having three steps to creating an encryption program that encrypts text. Step one, get input. Oh, if I can spell, get input. Step two, oh dear, sorry, idle doesn't like the keyboard shortcuts that I like, and so it does annoy me sometimes. Step two is process that input, and step three is output that input, or output result, should we say. And so you can see that step three is going to be something like print, and then we're going to print our what we're going to call it, our ciphertext. Cool, so we've done 2 out of 3 steps already. Step 2 might be a little tricky though. So it's not going to be that tricky. So what we're going to do is we're going to take our plain text variable, which could be any length of phrase. It could be a string that's just 1 letter, it could be 1,000 letters, we don't know. And we are going to take a look at each letter and perform some kind of shift on it. So I'm going to write a for loop. So I want to do something for every letter in my plain text. So I'm going to say for, let's create a variable letter. For letter in plain text, we're going to do something. So I'm just going to print letter to begin with and make sure this works. So if this is working, what I should see down here is it print out a single letter of the input that I give it, and then the next letter, then the next letter, and we should see that it goes through every letter. And let's print a maybe a dividing line just to show that it is working. So a little kind of thing there. So Control S to save, and what's run on a Mac? F5, cool. Enter phrase to be encrypted. So hello. Say it's run through the loop, so it said H-E-L-L-O-. So this for loop is running for every letter in plain text. It's printing a letter, then it's printing a hyphen. Then it's moving on to the next letter, it's printing that letter, it's printing the hyphen. Moving on to the next letter, printing that letter, printing the hyphen. And it's doing that for however long it is. Now, at the end here it hit an error. I've created this variable ciphertext and it doesn't exist, but I'm just going to comment this out. So now we'll come back to this in a bit. So just putting a hash creates a comment, and a comment is something that's not read by the computer when it runs your code. So now I should be able to press F5 again, entering phrase for encrypted. This is a longer sentence, and it will print out this is a longer sentence. Lovely, you can see it's even doing the spaces. Okay, so we can see quite clearly that we're looking at each letter now using this loop. Okay, for every letter in plain text, we're printing letter and printing this, but we don't want to print the letter. Now what we want to do is we want to declare our ciphertext variable. So our ciphertext is going to start as nothing, and I can get rid of this comment now actually because we can keep testing this by printing it out. So my ciphertext is equal to a blank string, an empty string at the moment, and for every letter in my plain text I'm going to do something to it. So I'm going to maybe create a variable called new letter, and new letter is going to be equal to something. Now the first thing we need to do actually is we need to use the ORD function. So if I come into the shell, I can just run Python straight off the bat, and I should be able to say ORD A, and that gives me a number. Now that's exciting. I could do ORD B, capital B, mind, and capital A, and you can see that's 66. So we're going to take advantage of something called the ASCII character set, where each letter in the alphabet has its own corresponding number that we can use. So I'm going to say letter code equals, and we're going to get that ORD of that letter. So whatever letter we've got, so if I did hello, the first pass through the loop would do a capital H, and it would get me the number 72. We can then make a new letter code. Oh, caps. New letter code is equal to our letter code. Now I'm being really verbose here. I could do this in much less lines of code, but I just want to make it clear to you kind of what we're doing. So my letter code is the ORD of my letter, what number represents that letter. My new letter code is going to equal my letter code, and I'm going to perform some kind of mathematical function on it. And so I'm going to do maybe times 2. Now my new letter is going to be equal to string dot to char. Not it. Okay, I didn't want to do string. I'm getting confused between languages. I can do cur, and I could do 65, and that will give me back a capital A. So you can see ORD A gave me a 65, and cur A gave me an A. So we can see we can swap between the number version of a letter and the letter version by using these two functions. So putting a letter into ORD gives me a number, and putting a number into chur gives me a letter. So I can say new letter equals chur with my new letter code. And then what I can do is I can add that to my ciphertext. So I'm going to say ciphertext plus equals my new letter. Let's take it for a spin. Run. So enter phrase to be encrypted. I'm just going to do hello. Cool, so you can see there that we've hit some kind of maybe Russian alphabet or something like that. Now, it's not actually done every letter. Why hasn't it done every letter? It's done 4. I'm not really sure why it's not done a 5th. That's a little bit odd. Times 2 maybe isn't the best. Let's do like add 1,000, see what happens there. Now this is for you to really play around with and see what works. Okay, that's given me some kind of weird nonsense. So you could just shift it to a completely different character set. You could do something as simple as doing something like -1, for instance. And if I was to run that, and I type in hello, okay, you can see that I just get some nonsense. And so you could do something that shifts the characters to a completely different part of the Unicode character set, or you could do something where you just kind of mix up the letters and just shift it a little bit down the alphabet. And so doing a kind of -1 or a +3 or something would be akin to doing a Caesar shift. So like the Caesar cipher, if I was to do hello, that would shift it. Or was it -3 for the Caesar? Oh, Let's try that. Okay, hello. So yeah, you can see there that we are kind of still staying within the English language, but I could do something like add 3000, and I could get something very odd indeed. There we go. So this is a way that you can encrypt your text. Now, let's wrap this up into a function. So let's do all this, and let's say def encrypt, and let's pop all of this and tab it in so it belongs to this function. So our encrypt function is going to do that. I'm going to write a main function as well. So def main, I'm going to say while running, and we'll set running to true at the start. Running equals true. While running, we are going to let's say display menu. Let's write display menu, print. Would you like to either print 1, encrypt, print 2, as a string, decrypt. Input, and let's just put /n so it's on a new line, although that should be on a new line anyway. Let's do your choice. Let's spell it properly. Your choice. Okay, so we display menu print. Would you like to either 1 encrypt, 2 decrypt, and then input your choice. Type number of your choice, and that will display our menu. And what we'll do is we will return our input. So let's say choice equals input. If choice equals 1 or choice equals 2 as a string, then return choice, else print invalid choice. Please try again. Well, what did I do? Where'd it go? Python? Are you kidding me? Did that just... What? Okay, it turns out there's like a mouse shortcut that will just absolutely nuke my Python file. That's great. Okay. Okay. So I'm gonna take this. I've put this into a function encrypt, and now what we can do is we can make our program a little bit more clever. So I'm gonna make a main function. We're going to make a variable called running and set that to true, and we're going to say while our program is running, we are going to display a menu. So that menu is going to give us a set of choices. So those choices will be def display menu. Those choices will be print what would you like to do? And the choices will be print 1, encrypt a message, and print choice number 2 will be decrypt a message. And we'll do a little bit of error checking here, so let's just pop in an input and say enter number of your choice here. We'll assign that to a variable choice, and we'll say if choice equals 1 or choice equals 2, return choice. This should be a string, and this should be a string. So if choice, because input always comes in as a string, so even if they type in the number 1, it will come in as a string version. So if choice is equal to number 1 or choice equals to number 2, we're going to return choice. Else, we're going to print invalid choice, and we are going to return false. Oh my lord, are you kidding me? Okay, so we've got our main function. I'm sorry, if I've cut this out in the future, I have just accidentally closed down this a few times and without saving it, and it's driving me a little bit mad because I don't mean to do it. Display menu. Okay, right. Third time lucky. Print. Enter. What would you like to do? Print. Choice number 1. What's choice number 1? Encrypt a message. Print. Choice number 2. Decrypt a message. And we will then say our choice is equal to input. And that input will be enter number of your choice here. Okay, now we can do a little bit of error checking. So if choice is equal to 1 or choice is equal to 2, then we are going to return choice. Else, we are going to return false. And we want to tell our program that they have chose poorly. Actually, what I'm going to do is I'm going to print. What am I going to print? I'm going to print invalid choice. And now we can say here, choice equals display menu, and then if choice does not equal false, or actually what we can do is we can say if choice equals 1, then we're going to do something. Elif choice equals 2, then we're going to do something. So what we're going to do if choice is 1, well, we're going to run our encrypt function. And if choice is 2, we're going to run our decrypt function. And then what we can do is we can run a little, we can say choice equals 2, elif choice equals false. We're going to, I think we can say continue, and that should just ignore whatever I do next. And what I'm going to do next is I'm going to say running. We're going to update the value of running, so we're going to say input would you like to actually let's not do that. Let's make this cleverer and let's put in a third option in our menu. So let's print number 3. We're going to say exit, and we say if choice equals 1 or choice equals 2 or choice equals 3, then return choice. If choice equals 1, so if choice equals 3, we're going to break. And if choice is false, then it's not going to hit any of these. It's going to whack back around and go into display menu. Let's pop a couple of line breaks here. Okay, now we just need to write a function for decrypt. So our decrypt function is going to be very similar to our encrypt function, apart from its name. And we're going to do the opposite of whatever we did here. So whatever mathematical thing you've done here, we're just going to reverse it, and that's all you need to do. So now I should be able to run this, and I've not called any functions to begin my program. So I'm going to come down to the bottom. It's happened again. Idle. So this is why I don't use idle. I really hate it. I think it's such a bad IDE. Maybe that's just me. Okay, let's scroll down to the bottom. I would really recommend working in anything else other than idle. And maybe I shouldn't be encouraging you to work in idle by using it in this video. Right, so I'm going to run main. Unindent does not match house level yet, so pop that back to the start. Let's run this. What would you like to do? Encrypt a message, decrypt a message, or exit? So let's start by pressing exit. Invalid choice. Okay, great. I didn't put these as strings, so let's pop these as strings. So input comes in as a string. So let's pop that there. Return choice. Okay, lovely. So if choice equals 1, so that's going to be a string. That's going to be a string. That's going to be a string. If choice equals 3, we're going to print quitting, exiting program. Cool. Let's try this again. What would you like to do? Enter the number of your choice here. So let's try and exit. Exiting program, finished. Okay, great. Let's run main again. What would you like to do? Encrypt a message, decrypt a message, exit. Let's encrypt a message. So I'm going to type in 1. Enter phrase to be encrypted. I don't like the formatting on that whatsoever, so let's just pop up here. Okay, yeah, I've noticed something I've not copied over. So enter phrase to be encrypted. I'm going to put a that, and enter phrase to be encrypted. I want this to be decrypted, so it's on my decrypt function. So enter phrase to be decrypted, and I'm going to do this exactly the same. /n. Okay, let's rerun this. So I'd like to encrypt a message, enter phrase to be encrypted, hello. Okay, so I've now got this that I'm going to copy, and I'm going to decrypt a message, so 2 to decrypt. I'm going to paste that in there, press enter, and you can see there that it successfully decrypted it and it has printed out hello. Now I think when we print these out, there's not much theatre with it, so let's make our output look a bit nicer. So print, instead of just printing ciphertext, let's print out some hashes. Let's print out a line break at the start and a line break at the end. And then let's print, encrypted text. Let's see how that looks. Enter your choice here. 1, hello. Cool. So that's there. That's much nicer. Okay. What I might do is I might get rid of Or I might just put this in here, you know, encrypted text, and then let's put in our ciphertext. And get rid of this. Cool, so let's just try this, and then I'll put it in the decrypt as well. So one, hello, Bosh, encrypted text, lovely. Okay, so let's grab this and let's put this into my decrypted. So down here, save, scroll down. Really don't want this to exit unexpectedly. Let's pop this in here. Now, this is a little bit confusingly worded. So in my decrypt function, this isn't my plain text, it's my ciphertext. So I'm going to cut that, I'm going to paste it here. And I'm going to cut my ciphertext and so just my terminology is right. So I'm going to start with my ciphertext. That's going to be my input. My plain text is going to be 0. 4-letter in ciphertext. Plain text plus equals new letter, and I'm going to output my plain text because I'm converting it back to plain text. So let's do it. Give it a final run. What would you like to do? So let's encrypt my phrase. There we go. So we have this wild sequence of characters, and then I'd like to decrypt my phrase. Lovely, that worked, and I'd like to exit now. Fantastic. We've made a little Python program that can encrypt a message, decrypt a message, and has a lovely little user interface as well. And we thought about formatting. Sweet.